So the presentation again about that boring topic, AI. And this is going to be a little bit. Do we have sound? We should have sound in our presentation. From the presentation. It should be really cringy with the sound. Are you able to enable it? Turn it on. This deconstructed slow core. Yes, no? Okay, so imagine a deconstructed slow core. Tape decay hymns, female vocalist, existential anti-melodies, amorphous catharsis, textual chaos. What it might be? What the musical performer is it? Maybe, I don't know. Maybe Beyonce, maybe something else. But actually, it is Suno.ai. And by the way, Suno.ai is one of ClickHouse users. They use ClickHouse to generate all of that kind of stuff. And if we talk about AI today, so generative AI is easy. We have a model, we have prompt, and it generates a response. And there is the model can be quite complex with a huge number of parameters, huge number of inputs that makes this model together. So my presentation today is about trying to look behind the curtain, trying to look how is the AI made, from what types of data, what types of data sets. And there are a lot of data on the internet, like HTML pages, YouTube videos, Spotify tracks. And the data sets like Common Crawl, which contains monthly crawls of the internet, about hundreds of terabytes of HTML pages. Wikipedia, which is much smaller but significantly more curated. GitHub, if you want to learn your AI model on the code. There are pre-processed data sets like ZPile, OpenWebText, FineWeb2. These data sets are created from Common Crawl, but with deduplication, with filtering, with removal of data with inappropriate licenses or just inappropriate data. There are social networks like Twitter, Reddit, 4chan. I think if you train your model on Wikipedia, it will be a very boring language model. If you train your language model on 4chan, it will be not so boring language model. Let's take a look at data sizes. Common Crawl is about 500 terabytes, half a petabyte, with 2.5 billion web pages. It is a certain part of the internet, not all the internet. And if we compress it, it will be about 100 terabytes with, and if we extract only the text, it will be just tens of terabytes. Wikipedia is quite small, just a few gigabytes. FineWeb is interesting. Let's take a look what it might be. And the good part is that many of these data sets are available for download. They are hosted on places like Hugging Face. And Hugging Face provides an open API to download these data sets. For example, for find web 2, we can make this SQL query that will use the URL table function to request the API of Hugging Face and extract the list of files, Parquet files, with their metadata. We can see it is 26,000 files, 46 terabytes of data. By the way, the first thing I'm trying to do when I'm presented with any type of data set is I'm trying to load this data set into ClickHouse. Because what if this data set is somewhat unusual? Then I will test ClickHouse on that unusual data set. And if something will go wrong, I will be happy because I can modify ClickHouse, I can fix it, I can improve it. If the data set loads perfectly, if everything works fine, I am also happy because I know everything works fine. So this way I can be happy every day. Every day a new data set, try to load it and be happy. So find web is 46 terabytes of Parquet files, 26,000 of Parquet files, about 25 billions of records, 73 terabytes of uncompressed text, and 81 terabyte with metadata. So let me do this query just to list these 26,000 of URLs. And then I can create a destination table inside ClickHouse. And I don't even have to create the data table structure. I create it as create table, empty as select, according to this Parquet file. And the data structure is inferred automatically, like URL, date, language, the number of tokens. And now let's load all of this data in parallel. First, I will use ClickHouse to generate 26,000 of insert queries by a template. Insert into find web, select star from URL. And I will run all of these insertions in parallel with 50 threads. And I have two questions. The first question, did Hugging Face ban me? What do you think? No, surprisingly, it let me did all of this. And the second question, how long did it take to load this 81 terabytes of data into ClickHouse? What do you think? Seconds. Any more hypotheses? 5 minutes. And I will also ask which database do you use? Which database do you use at work, typically? Okay. You should have said ClickHouse and Postgres. Any more hypotheses? 2.5 hours. 2.5 hours. Do you use Oracle at work? Okay. Any more hypotheses? More guesses?
How many nodes?
That's a really good question. The backend is ClickHouse Cloud with 25 replicas.
25 replicas.
Huh?
Oh, okay, it'll be minutes at most.
Okay.
Seconds, really.
Actually, I like your answer. Let's take a look. Also keep in mind that it is limited not only by ClickHouse, but also by the speed how Hugging Face is going to give us this data over the network. It took 72 minutes, 1 hour and 12 minutes. And interestingly that in ClickHouse, these 46 terabytes of Parquet files were transformed to just 33 terabytes of data. And it is interesting. Why? Because the Parquet data format, it is a column-oriented data format. ClickHouse is also column-oriented. Parquet uses ZSTD compression. ClickHouse also uses ZSTD compression. There should be no difference. But the point is ClickHouse just does it better. ClickHouse compresses the data better. Now let's try to explore this data. It contains of HTML pages, but from what websites? Let me do a query, select domain and count from FineWeb. This demo is pre-recorded and it should play. Okay, so now the query is running 200 gigabytes per second. It processed about 1 terabyte of data, almost 2 terabytes of data. And the websites are Wikipedia, The Guardian, Business Insider, Fox News, Fanfiction, Telegraph, TripAdvisor. Okay, so mostly Wikipedia and the news, but also Fanfiction. I don't know why, just for the balance. Okay, actually, this data set is not enough. There are many, many more data sets. For example, for science papers, there is archive, or archive, how do you pronounce that? It is quite small, and if you learn your language model on archive, it will learn to speak in a passive voice. The passive voice will be learned. GitHub is probably one of the largest. If you take all repositories with thousands of forks of Linux kernel, it will be 300 terabytes. If you want to learn multimodal data, there is Flickr with billions of photos with fairly good licenses. And the point is all of these data sets will fit into just a single service in ClickHouse Cloud. Because everything will fit in just a single service in ClickHouse Cloud. ClickHouse Cloud is almost infinitely scalable. So you can load and then explore these data sets. Now let's try to analyze different characteristics of them. And the first thing I do, it looks surprisingly simple. Maybe even a little bit stupid. So I will just analyze the distributions of words in the data and compare them between different data sets. So the first query will lowercase the text, extract tokens, which here are just words. It will extract into an array. The function arrayJoin will flatten this array. And for each of them, we will insert just a single number, 1. And the table, it has a summing merge tree engine. And the table will sum all of this data by tokens. In the second query, I do something a little bit more interesting. Instead of tokens, I extract bgrams. So we have a function named arrayShingles. And with value 2, it will extract pairs of consecutive tokens, which means bgrams. And now let me do this query. And this query will take the distribution from Hacker News and from Blue Sky and find the most contrasting tokens. Among the popular tokens, we will find which are the most visible in Blue Sky and the most visible in Hacker News. Let's take a look. We have a query. Let me run it. And it is quite fast. On Blue Sky, the top tokens are social, her, him, love, please, hope, today, so much, yeah, fun. On Hacker News, the tokens are data, Google, system, problem, that it, there are. I find Blue Sky is way more interesting than Hacker News. And I did this comparison across many different data sets. For example, on Reddit, the top contrasting tokens are action, level, pretty, content, and yourself. And I will not say what goes before yourself. And on Wikipedia, the top tokens were uninteresting, but the least popular token is interesting. It is actually you. You are not popular on Wikipedia. Me neither. I don't have a page on Wikipedia. Now it's interesting to do this comparison across all the internet. So we have this data set, Fine Web 2. And it already contains almost all the websites. Reddit, Twitter, Wikipedia, news websites, Bloomberg, fanfiction, etc. And I will do a pretty interesting query. It is just a few lines, but let me explain. I will define a vector size 1024. And I will fill this vector for each website. So first, I will take every token from the content of the website, calculate a hash, city hash 64, take a remainder of division by the number of dimensions, 1024, and just increment a number in that dimension, add 1. And then I will just repeat this operation for all the dimensions. I'm using the sum for each function that will take arrays and sum them horizontally for every dimension. And then I can calculate a cosine distance between these vectors. And supposedly, it might work. Let's do this experiment. Let me copy-paste some query. OK, cosine distance, what is similar to ClickHouse.com. And ClickHouse.com is at the top. Then imply, red panda, planet scale, source graph, confluent, dgraph, airbyte. And yeah, so it works. Apparently, I did this query. It is not so complex. It did some magic, and it worked. Now let me do another query. Trends on the internet. This is the trend of love on Reddit. I have Reddit dataset, and this is the trend. This is the trend of ClickHouse. ClickHouse is growing even more. This is Hadoop. Hadoop is not growing. What about blockchain? This is blockchain. It is quite volatile, I would say. It was popular in 2018, and now it is also quite strong. But ClickHouse grows faster. OK, now about multimodal datasets. If I have a dataset with 1 billion of pictures, photos, what would I do? What would you do with 1 billion of pictures? Categorize. Yeah, interesting idea. I want something more like visual. Extract faces. Also, really interesting idea. I did not do that. What else? Yeah, these photos have a lot of metadata and quite interesting data. And some of them are even geotagged. I will just place all these photos on a map. This is the map with the density of these photos. And I can do even more, like press this button, and it will do hundreds of queries to ClickHouse to find the best rated photo for each location, for each tile. Every tile is a result of ClickHouse query across this data set. And I can even generate a report with different tags, different metadata, filter by different metadata. And this website is entirely public, so you can even look which photos are the most popular in Australia, and specifically, how do the characteristics of photos compare between Sydney and Melbourne? What do you think? What do you think is more beautiful, Sydney or Melbourne? I still have to get my impressions, to sort out my impressions, because I did not decide yet. And actually, it depends on you. I was in Melbourne just 2 days ago. I am here. And we will see. Okay, some takeaways. ClickHouse makes everything easy. If you have large, messy data set, complex data set, just load it into ClickHouse. And it will be more fun if you use ClickHouse. And supposedly you can put all the internet into ClickHouse, and then the internet will work faster. Okay, now back to the a little bit more boring topic. So ClickHouse is the database for AI. It supports vector indexes, approximate and precise vector search, user-defined functions. It can work for data preparation, for data analysis. It can work as a backend for AI agents. One of the recent features is the vector similarity index. And it is as easy as here. I would only change one thing. I would use cosine distance instead of L2 distance, but both distances are available. Or I would change float 32 to bfloat 16, which we also support. Vector indexes are using HNSW as the data structure, so they are quite practical and fast. Now let's take a look how you would use any database like 50 years ago. 50 years ago, it would look like here. It's like ClickHouse running on a machine from 80s. It works. You can do queries, you can type these queries as usual, and it is fast. It is fast, and I really like ClickHouse client. It's CLI. I use it every day. And in this example, we generate reports on top of the data set of property prices in the UK. Now, what was that? It was an example of classic real-time analytics. You are the user, you type a query, you get the result. Or you have an API layer, an application. You use this application do queries to the database. And it is kind of boring today. Today we have something more interesting. Agentic analytics. And it looks like that. You have an agent that does everything for you. You just tell what to do. And it will figure out what is the schema, what databases exist, what are the tables, and run your queries. And present the results as nicely as you want. The difference is that now for a single request that you do for an agent, this agent could generate tens or even hundreds of SQL queries. And the fact that ClickHouse is the database for real-time analytics, surprisingly, this is even more important for AI agents. And this is what we name agentic analytics. So what agentic analytics actually need from the database? High-performance queries, low-latency data, security controls and access controls, context for the data, and this is everything what ClickHouse does. So in our company, we created an AI agent named Dwayne, which means, it's just a random word, but it means data warehouse AI something. For business analytics. And until recently, we mostly used Superset. We created dashboards, and it was difficult to find the right dashboard, and it was especially difficult when, like my colleague Aaron asked asks the data warehouse team, could you please create a report? Could you please create another report? And they are sleeping at the time, and they wake up and create that report, and then it is difficult to find. So instead, now it is mostly done through our agent. You just ask questions about our production database, which is petabytes of data about the resource usage of our cloud services in our infrastructure. And it gives the report, it generates the result. Now it's like tens of millions tokens every day. It is quite widely used in our company. What about the adoption? So initially, ClickHouse was accessible for database people like me. I can use ClickHouse client every day, and actually I really enjoy writing SQL queries in the ClickHouse SQL dialect. Now we have ClickHouse MCP server. So you can use it on your machine, and we also have a remote MCP server, so you can connect agents to any remote ClickHouse server, including ClickHouse Cloud, including all the required security and permissions. So what we have now is that developers can use ClickHouse to develop the tools. Let's take a look at the tools. Here is ClickHouse Cloud Console. I will just enable MCP server with a single click. Here it is. And I get the endpoint. Let's copy it. Now let's go to our favorite development environment. And here is an application that is generated in that environment using the ClickHouse MCP protocol. But also I can use the chat interface directly inside this environment. So let's use the data in ClickHouse and find good investment opportunities in London. Not sure if there are any. Probably in Sydney there are more. Maybe in Melbourne. So here is a report with cheap, relatively cheap houses. Not cheap. No, most expensive. 500 million or something. And at the same time, it generated an application. And it can modify the application to accommodate our use case. Like here. All of that using the database and using agentic analytics. Top 10 cheapest boroughs in London. Rhondda, sign-on, whatever. So now we accommodated developers, but also we need to accommodate literally anyone else. And it is possible because with this interface, literally anyone else can query databases. It makes the data more accessible to different people inside organizations. More people can extract more value from the data. And I would say, yes, it will increase the load and the demand for faster databases. And I'm really happy with that, because ClickHouse is the fastest database, and it is the best suited for this type of workloads, agentic analytics. So welcome to check the use cases examples at clickhouse.ai. Now we have this fashionable domain. Now is, thank you.